Introduction to computing measuring units. Normally, we are using measuring units in our day-to-day life. So let me give you an example. Imagine you have got an news, you have got a news that 20 friends will come to your home. 20 friends will come to your home. Then they are coming for you the dinner. They are coming for the dinner. So you need to prepare a fried rice. You are going to prepare a fried rice. For that one, you should buy rice. You should buy rice. So I'm not good at cooking. Let me assume you need 5 kg of rice, 5 kilograms of rice. So here we have used the measuring units, kilograms. Another example. So you are going to prepare a birthday cake. You are going to prepare a birthday cake. So you should be able to cut 25 pieces from this. So I think 2 kilogram of cake is enough. But to make a 2 kilogram of cake, you should measure. Imagine, I think we can add 1 kg of flour and 500 grams of sugar. So here also we are using measuring units, and maybe 10 eggs, 10 eggs. But here we don't have measuring unit. Eggs. Egg is a measuring unit. We don't have a international way of measuring eggs. And imagine, so you are going to visit Sigiriya these days in this hot season, Sigiriya. So there, Miss Lakshani will ask from someone, shall we buy a water bottle? Then they will reply, uh, what is the size of the water bottle, size or the amount. So Miss Lakshani will reply, I need 1 liter of water bottle. I need 5 liters of water bottle. I need 10 liters of water bottle. One bottle of 10 liter, one bottle of 5 liters, one bottle of 1 liter. So here we are using the measuring units. So why we have to use measuring units? Because we should specify the requirements. We should specify the requirements. In when it comes to computing, why we need the memory units? Because they are the building blocks for measuring data in computers. What are memory units? Memory units are the building blocks for measuring data in computers. They are relative things. They are relative things. So we are having several measuring units. So in relative to this unit A, here we maybe have one. We'll see. We may maybe have 9 A's, 1 2 3 4 5 6 7 8 9. So we will tell here we have 9 A's of data or something. Likewise. So this is the basic theory. So now let's see what are the actual things, actual measuring units we are going to use in our computer measuring journey. Basic units of memory. So we have bit. We called it as 0 or 1. So I have shown you several videos. We have done some activities regarding this. So I have shown you how a bulb works. So you have switch here and there's bulb. So when it is on, we can say it 1. When it is off, we say it 0. So according to the 1 and 0 state, this bulb is going to glow. So here whether it's 1 or whether it's 0, we called one such thing as a bit, bit, capital B, simple it, bit. And then 4 of this 4 bits will be called as a one nibble. 4 bits 4 bits are here. 4 bits are called as one nibble, right? One nibble. One 4 bits are a collection of 4 bits are is called as nibble. Then 4 bits, a group of 4 bits called as nibble. It's like this. 12 eggs. 12 eggs. We call it as a dozen. 12 eggs, we called it as a dozen. So 6 eggs, we called it as half a dozen. Like that. Half a dozen. Like that. 4 bits, a group of 4 bits is called as one nibble. Then here, so skip this one and see 8 bits. This is popular. 8 bits. 8 bits, a group of 8 bits is called as one byte. One byte. One byte. So if you go and see your files, sometimes you can find byte-sized files, right? So let's check how what is the size of this uh, PDF. It's here. It says 356 KB. KB means kilobytes, or in bytes it's 363,335, almost 3 lakhs. Yeah. Almost 3 lakhs of bytes is there. So bytes, practical example. So for the videos, it's going to be gigabytes. We'll discuss them later. And 1 kilobyte is 1025 of bytes. Here, 1025 of bytes, not bits. So here, how many bits are there? 1 byte is 8 bits. So this should be multiplied by 8. So then we will get the bit count. Then we will get the bit count. Here 1025 bytes. Bytes equal 8 bits. So we should convert 1024 multiplied by 8 to get how many bits are here. So let me do the quick calculation. 1025 by 8. 1025 multiplied by 8. It's going to be 8192. So here 8192 bits. 8192 bits equivalent. Then 1025, hereafter it's easy to remember. 1025 of bytes is going to be called as here 1025 here 1 kilobytes, right? 1 kilobyte, sorry, 1025 of bytes is called as 1 kilobyte. Then 1025 of 1 kilobytes or kilobytes is called as a megabyte. So here how many bits? Here 1025 kilobytes. So first should convert kilobyte to byte. So how to convert kilobyte to byte? 1025 kilobytes to bytes. 1025 bytes. Then how to convert it to bits? Again multiplied it by 8. Here 1025 bytes, and then we have to convert it to the here 1025 megabytes to kilobytes and kilobytes to bits. Then that's fine. Then again 1025 of gigabytes. So, megabytes times 25, we called it as gigabyte. 1025 of these things is called as gigabyte. Then 1025 of gigabytes called as terabyte. So it continues terabyte, petabyte, petabyte, exabyte, exabyte, zettabyte, and zettabyte. This one yottabyte, right? So how low? How what is the size of this one in bits? So you can use a calculator, right? So yottabyte. So we'll do. So if you go to the Google, you can calculate it. Bits converter. This one you can use any program here. Amount 1 units bits. So here bits in 1 bit in 1 bit in here if we add bytes, here we have bytes, right? So here bit is 1 byte, in bits it's 8, in kilobytes likewise. So we'll see kilobytes calculate. All right, here. So here you can see. So no, 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 not like that. Just don't think about that. Just memory unit, because we can't provide a exact definition. It's just 1 0, and don't think about too much it. So I will provide some videos. So you should see those videos. And it's not regarding to the uh, not not like that. Don't think about that, because the thing is uh, it's in the binary code, but here it's a little bit different, because in the binary code we are using the numerical value, but here this is just a measuring unit. Here this is just a measuring unit, and in the binary code you are working with that. So here don't think about too much, just think about the size. Think about the size, right? So if you go here, so now can you see amount kilobytes? So 1 kilobyte, 1 kilobyte, yeah, 1025 bytes, yeah, 1025 bytes. And here bits it's megabyte. Okay, I think there's a mistake here, so let's go for another one. We'll type like kilobytes, kilobytes to bits conversion. Right. All right, we have it, right? So here we have. Okay, so 1 bit. Okay, right. So this is going to be seen here, right? So first what we have. So let me split the screen. It's easy. Okay, now we'll see. Now we can see. So if we select one nibble, can we select nibble here? Is it there? No, it's fine, right? Nibble means 4 bits, right? We'll skip it. Then we'll get the byte, right? 1 byte. Here in bits, 1 byte. So if you go to byte here, 1 byte, it's 4 bits. 1 byte's 4 bits. It's true. 1 byte, 4 bits. It's true. Then this one is okay. Then kilobyte. So here, if I'm going to select kilobyte, so it's here it says 8000 bits, 8000 bits, right? But stick with the things given in the note, right? Because the thing is sometimes they are going to get this kilo. Kilo means the multiplication, the factor as 1000. right? So that is the that is a little bit misleading, right? So here it's asking, is a kilobyte 1000 or 1025 bits, right? Here, yes. Originally, a byte was considered a collection of 8 bits. The smallest number were able to express a number, letter, or character within binary. A kilobyte is approximately 1000 bytes, especially 2 to the 10th power or decimals from 1, yeah, 124 bytes. And here you can do your own research. Is here. So we have calculators also. So right. So let me do something like this, right? So let me go to ChatGPT. This is how you use these things. So you have arise a question, right? So there's a misunderstanding. So let's ask from it, right? So here in some places they convert 1 kilobyte to byte like this. You can say kilobyte multiplied by 1024 equals bytes. And some places they calculate it like kilobyte multiplied by 1000 equal bytes, right? What is this? Please explain. Right, this is how you give your prompt. So we'll see what is the ChatGPT's answer. Okay, here the difference comes from two different ways of defining a kilobyte. Here, binary base two system. Here in this thing, in this methodology, binary based system, 1 kilobyte, 1 kilobyte is considered as 1024 bytes. So where does this 1024 comes from? It is like this. So it comes from the binary system. So let me give you more details about the binary system. It's like this, powers, powers. It's like this. We have powers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And here the base is 2. Binary base 2. Base is 2. Then we will see the answers. So 2 to the power 0, it's 1. 2 to the power 1, 2. Then 4. Then 8. Right? Then 16. Likewise, it's expanding. 32. 64. Yeah, 128. Then 256. Right? Then 512. Then 1024. So here 1024 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 10th power is the 1024. So the 2 to the power 10 means 1024, right? So this is how it's worked here. So if we use the base 2 system, this one, computers use binary base 2 because they operate with bits, zeros and ones, right? In this system, 1 kilobyte equals 1024 bytes, 2 to the 10 bytes. This is used in RAM memory, file size and computer storage calculations. Example 1 KB 1025. 1 megabyte, so 1024 of kilobytes, and 1 gigabyte 1024 of 1 megabytes, right? But when it comes to the decimal system, here two systems base 10, then 1 kilobyte or kilo means 1000 there. So imagine this one. So how many grams are there in a 1 kilogram? 1000 grams. In 1 kilogram you have 1000 grams. In 1 liter, how many milliliters you have? You have 1000 milliliters. So there you are not talking about 1025. 1025. Right? So two different things here. If they ask to get 1 kilo, yes, base 2 system, you can use 1024. If they ask base 10 or decimal one, you can get this one. You can use 1000 as the number for kilo. Kilo, K. Here it's 1025. Here, if they ask to get the decimal system, it's going to be 1000. Same thing, but it's two different scenarios, right? So let's see what are the other answers given by ChatGPT. Then, why does this cause confusion? A 500 GB hard disk manufacturers use 1000 base units here. So some manufacturers are using 1000 base units. So they are using kilo as 1000. Appears smaller on a computer which use 1024 base unit. It's true, right? So here, so it's true, right? So here this say 500 GB hard drives. So the manufacturer use 1000 base system. 1000 base system 500 GB appears smaller on a computer which use 1025 base unit. That's true. So here 500 GB. So they how to convert this 500 GB into the binary? Sorry, the bits. If we use the uh, base 2 system, we can do something like this, right? So let's try to convert the here 500 GB into bits. So how to do here? We are here 500 GB means gigabytes, right? So 500 gigabytes, 500 GB equals, so first gigabytes to megabyte, yes, megabyte, gigabytes to megabytes, 1024, right? We if we are using the base 2 system, so it is base 2, B2, base 2, 1024, right? So 500 GB to gigabyte, megabyte, then megabyte to kilobyte, again 1025, 4 megabyte to kilobyte, then kilobyte to bytes, again 1024, then bytes to bits, you can convert that to 8, right? So here gigabyte, megabyte, kilobyte, bytes and bits. So yes, so if you calculate it, so let me cal and show you. You can manually do, but I prefer to do it like this. 500 multiplied by 1024 multiplied by this 1024 multiplied by 1024 multiplied by 8. So it's this number. So let me take a screenshot. It's almost 4294 billion, right? So save this number. Then this is base 2. So if we use the base 10 architecture, base 10, it's like this: 500 multiplied by 1000. Yeah, how many thousands? 1, 2, 3, and 8, right? So 1, 2, 3, 2, 3, and 8. So we can say it easily like this: 5 multiplied by how many zeros? Here, 2, here 3, 3, 3, 3. So 2, 3, 5, 5, 3, 8, 8, 3, 11. So we can tell it as 5 multiplied by 8 multiplied by 10 to the power 11, right? So here it's almost how much? 40 multiplied by 10 to the power 11. So here it's going to be 4 multiplied by 10 to the power 12. So we can easily write this number if you want. 4, then 12 zeros, 3, 6, 9 and 12. 9 and 12. And so this is the number. So if we compare it with the previous number, this is smaller. Here you can easily see, right? So the number we got there was 4 and 12 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3, and here. Here you can see the difference. Here almost 294 million difference. Sorry, billion, right? So here 4294 billion. So if you get the difference here, almost 294 billion difference. It's a significant one, right? Significant one. So that is the problem, right? So then what else we have? Is because here 5, here we have 500 million billion bytes equal divide by here this one is 565 GB in binary format, right? It's true. So we have discussed. Solution. Here they have, to avoid confusion, a new naming system was introduced. They have introduced a new naming system. So there 1 kilobyte. 1 kilobyte equals 1000 bits decimal, right? So this is used by the manufacturers. This is used by the manufacturers. And here there's another one. It is called 1 kibibyte. Kibibyte, KIB. 1 kibibyte equals 1024 bytes. Binary used by computers. So it is two different things, right? So here similarly, 1 MB equals 1000 KB kilobytes, but 1 mega kibibyte equals 1024 kibibyte. Anyway, so if it is about RAM, file size or operating system, use 1024. If it is about the storage, you can use the 1000, right? So see, sorry, how the things have evolved. So this is invented because of a problem caused by the hard hard device manufacturers, right? Here if it is about storage device, you can use 1000. If it is about memory in the sense RAM, files or operating system, use 1024, right? So anyway, you can remember both terms, right? Both terms. Here this is about memory means it's basically about the RAM and the operating system OS. So please use 1024. It's better because it's mentioned, right? All right. So let's do some little conversions. So here you have online converters also. Then I think you have got the point, right? Then here 1 kilobyte. So they are using what? They are using 1000. They are using the 1000 option here, right? They are using the 1000 option. So if we change this to the 1024, it's good, right? Kilobytes to bytes conversion for using 1024. Okay, here convert kilobytes to bits, digital storage conversion, right here. So it is about storage, right? So here enter kilobytes. Here if we add 1 kilobyte and press calculate bits, kilobytes in bits, it's 8192. Is it correct? So we can do it manually. So let's do it manually. So let me open the paint. I think it's easy. Okay, so here 1 kilobyte. So first you draw 1 kilobyte equals how many bits? So go to the chart. 1 kilobyte equals 1024 bytes. So 1024 bytes. So why we are using the bytes here? Because we are thinking about the RAM or the memory, not about the hard disk. So this is the base 2 system. If you use the decimal system, you can use 1000 here bytes. So how to convert it to the bits? Again multiplied by 8. So here 8 for 32, 3, 8 2, it's 16, 19, 1 and 1, and here 8, 8192 bits, right? So the answer is correct, 8192 bits. So if we need to convert 5, if we change it, so here if we change it to I think it's no idea about this. Yes, decimal numbers, right? So decimal numbers, it's just the numbers, right? So here they have given the definition also, and here the example, kilobytes multiplied by 8192 bits. So here you have some examples. So conversion table, here you can see. Here you should select digital storage from 2. So let's click convert 1 megabyte to what? Megabyte to bytes. Go to conversion. So this one here, convert megabytes to bytes, right? So here if I add 1 megabyte to bytes, how to convert 1 megabyte to bytes? 1 MB, 1 MB equal megabytes to bytes. So go to the table. You should remember these things. 1 MB equals 1024 kilobytes. 1 MB equals 1 megabyte equal 1024 kilobytes. So you can specify 1024 kilobytes. Then what? You should convert 1024 kilobytes to bytes first. 1024 multiplied by 1024 bytes. Then you should multiply it by 8. Then 1024 multiplied by 1024 multiplied by 8 is the answer. So you can convert, right? So 1024, 1024, 8. 1024, 1024, 8. 1024, 1024 to 8. It's going to be 8,038,008. Sorry. Yes, 8,388,603. So let's check whether it's correct or not. So here 1 megabyte, it's going to calculate to bytes, right? Bytes. So this is 1000 megabytes. Yes, here this is bytes. So if you need to convert it to bits, you should select the bit and go to auto type. Right now we had 1 here, now it's 1 here. 8,388,608, right? That's it. So that's how you calculate. If someone gives in GB, you should be able to convert it using this, right? For your unit test, you have such things, right? So then same for this exabyte, zettabyte, yottabyte also, right? So you should multiply 1 zettabyte in 1024 to convert it to exabyte, then again 1024 to convert it to petabyte, then to terabyte, then to gigabyte. Likewise, you should convert, right? So now we are going to see the real world examples here. 1 KB of thing, a short email text, kilobytes. 1 MB, a typical photo, a photo, a low quality photo in your computer or the mobile device is actually 1 MB. And gigabyte, a movie or smartphone video, smartphone storage. So this video, so I'm currently recording it, this will be around 1 2 GB. So you have experienced those things. And terabyte, hard disk. So this hard disk, it's 1 TB of hard disk. This one here, this is one physical device, so it's 1 TB of hard disk. Then what else we have? We have smart storage, smartphone storage, 128 GB, 512, 64 GB, especially in Apple devices. And laptop hard disk, 128 GB SSD, 256, 512, 1 TB. External hard device, you can find from TBs to 10 TB, 1 TB to 10 TB likewise. Okay, so that's it for today. So you can follow these links. So I will add this one also to your Google chat, and also you can use the AI tools to clarify things. So I have given you this explanation here how to convert, and there are two things. When it comes to the RAM file size operating systems, you can use the 1024 way to define a kilo, and when it comes to storage, you can use 1000. So mostly in the paper or the things we convert in this module, you can use 1024. It's better. Then we can do some examples. All right, so you can do these questions.